So this lesson is about scale drawings. A scale drawing, it's a reading from the top of the page. A scale drawing has exactly the same shape as the original object but is a different size. All scale drawings should show the scale ratio. So you can see an example of a scale drawing here, one that you probably have seen something like this before, a house plan or maybe a garage plan, not a whole house. Where obviously that drawing that the builders use to make the house is not the actual size, it's a scale drawing of what the real size is going to be. And you can see down the bottom here, there is a ratio, 1 to 100, which means the first number represents the measurement on the plan and the second number represents the real life measurement. So if 1 centimetre on the plan represents 100 centimetres in real life, or metres, it actually doesn't matter what the units are, because remember, ratios, you can use whichever unit you like, it just has to be the same for the first number and the second number. So the real life building will be 100 times as big as this scale drawing. And that's what this next part here says. A scale ratio, 1 to 100 means that the actual or real lengths are 100 times greater than the lengths measured on the diagram. Okay, so we're not going to have too many complicated diagrams like this, but that is a real life place where you would see them. Most of the questions we're going to be doing though will be a lot less complicated looking than that. Okay, so when using a scale drawing to represent an object, you use a scale ratio. We just talked about that. The first number in the ratio is always the drawing length. Always make sure that you put them in the right order. And the second number is the actual length, real life length. So it is always useful to have a scale beginning with the number 1, and then the second number can be referred to as the scale factor. So like me saying it's 100 times as big, it's a scale factor. Scales that do not start with a 1 can be converted using equivalent ratios. So there is going to be a couple where we won't have a 1 at the beginning. So there's a little diagram here to help us convert. In some of the questions, I'm going to be giving you a measurement on a plan or a map, and you need to convert them into the real life measurement. So if I have the scale or drawing distance, you have to multiply by the scale factor, following that arrow, to get over to the real life distance. Okay, however, if I give you the real life distance and I want to go backwards and find out what it is on the map, you're going to have to divide by whatever the scale factor is. Okay, so that's a little bit of a reminder on how to get from one thing to the next. We'll be going both directions. So we've seen this one already, but we need to know this as well. We're going to have to, because we might have a map that has centimetres or millimetres, tiny little measurements that might represent kilometres in real life, we're going to have to be converting between our length units. So just a reminder on how to do that, which is why we have this diagram here. Okay, question 1. Find the actual distance for each of the following scale distances. Convert the actual distance into an appropriate unit. So the scale that we've been given on a map, it says here is 1 to 10,000. 1 something on the map is 10,000 in real life. So back to this diagram, if I have got the map measurement, the scale measurement, if I want to get to the real life one, I have to go this way and I have to multiply by the scale factor. Okay, so down here, my measurement is 2. My scale factor is this number up here. As long as that first number is a 1, my scale factor is the 10,000. Okay, so I'm going to times that by 10,000. Now, when you times those together, we get 20,000, but 20,000 watts. What is the unit of that measurement? Yeah, if I have put 2 centimetres in here, it means that that is going to be measured in centimetres. Now, it does not make sense to talk about 20,000 centimetres if this is a distance that I have to travel in the car. I want a much more realistic measurement here. So let's convert that into, let's go the next one, which will be metres, the bigger unit. To change centimetres into metres, what do you do? divide by 100. So you can write a little divide by 100 if you need that little reminder. And dividing that by 100 will give you 200 meters. 200 meters, that means. You could also go to kilometers if you wanted to. That would be 0.2 kilometers. But we tend to just go to the biggest unit that we can without having to go into a 0 point something. Okay, we could go, like it was 1.2 kilometers, that would be okay. But we don't want to have 0 point. We want to have at least one whole of the unit. Does that make sense? Okay, so we're going to stop there at 200 meters. So 2 centimeters on this map is actually 200 meters in real life is what that means. Let's try it again. We're going to use the same scale factor for all of these ones, the 1 to 10,000. This time I'm given a measurement of 5 millimeters on the map, which means I have to times by the scale factor again to find the real measurement. So 5 times 10,000. 5 times 10,000 obviously equals 50,000. But because I put millimeters in this time, there's going to be millimeters as the unit for that. Okay, don't like to measure 50,000 millimeters. Let's change it into something more realistic. The next unit, the next bigger unit is centimeters, right? So how do I change millimeters to centimeters? Divide by what? Not 100, 10. There is 10 millimeters in a centimeter. So we divide by 10 and that gives us 5,000 or 5,000. We're now in centimeters. That's still an awful lot of centimeters. So let's go to the next unit again, which would be meters. How do I go from centimeters to meters? Yes. So dividing by 100 will take off 2 more zeros, which will make 50, and we're now in meters. Okay, don't want to go to kilometers because that's going to turn it into a 0.05. Okay, too small. Stop there. Okay. And one more time, if I have a 14.3 centimeter measurement on my map, to convert that into a real measurement, I have to times it by my scale factor, which is 10,000. That makes 143,000 centimeters because my original measurement was in centimeters. Very, very big number, so we're going to change it into something more realistic. The next unit to change into will be meters, and to do that I divide by 100. Okay, so dividing by 100 will take off 2 zeros, which will make 1430 meters. Okay, that's a little bit better, 1,430 meters. But this one we actually can go to kilometers and still have more than one. How do I change that to kilometers? Yeah, Ethan's telling me all the answers. All the rest of you still asleep today. Good job, Ethan. Divide by 1,000 is 1.43 kilometers. Okay? So hopefully that is easy enough to follow. Just remember the key idea is if you've got the scale measurement, you want to times by the scale factor, and then it's just a matter of converting your units down into something more reasonable. Anton?
Need help with the question?
Oh, it's still going. There's still more examples on the next page. The next type, though, on the next page, question 2, we need to go the other way. So it says a model car has a scale of 1 to 200. Okay, so new ratio that we're using here. Find the scaled length for these actual lengths. These are the real life measurements. Something in real life measures 3 meters, and I want to go backwards and find out what it would be on my scale drawing. So what do I do? Before I was timesing, what do I do if I'm going back for the map diagram? The map measurement. Do I need to go back to the diagram? Back here? So if I have got my actual real life measurement, I need to go this way, which is to divide by the scale factor to get to the scale length. Yeah, we're dividing. And that is often the part that tricks people, is when do I times and when do I divide, which is why that diagram is super important, and please make sure you all put it on your study sheet. Okay? All right, so we're going to start with the 3 meters, and because we're going to the scaled measurement, we need to divide by my scale factor, which is a new one. What's my scale factor this time? My ratio, what did you say, Joey? 200. Yeah, so up here in my ratio, the 200, as long as that first number is a 1, the 200 is my scale factor. So 3 divided by 200, and don't be concerned here, it will be a very little number. It's 0.015 meters. Type in your calculator, it's good for you guys to do this with me. Now that's really small because we don't usually measure stuff on a map or a scale drawing in meters. That's not a realistic unit to use, is it? Okay, so now I need to go from a bigger unit into smaller ones that are more realistic to use on a map. So I want to go from meters to centimeters. How do I do that? Wrong way. By? Yes, Ethan, good job. So times by 100 to turn that into centimeters. That is 1.5, because times in by 100 moves that decimal point over 2 jumps. So 1.5 centimeters. That's a lot more. That's something you can visualize on a map, isn't it? So 3 meters in real life is really a 1.5 centimeter drawing if you do it to that scale on your piece of paper, is what that means. Okay, let's try it again. 500 centimeters in real life. If I want to turn that into a scaled measurement, I have to divide it by my ratio, my scale factor, which is 200. 500 divided by 200 is, anyone got it? 2.5, excellent. 2.5 what? What's the units? Centimeters, good, the same as here, centimeters, and that one's going to be centimeters. I don't actually need to change that because that's actually already something I can use, isn't it? 2.5 centimeters, we can measure that on a map. So we can leave that one, don't need to change any units at all. Done. Okay, last question, number 3. Determine the scale factor for the following situations. So the first 2 questions, the first one was I give you the map measurement and the scale factor, and we had to find the real life measurement. Second question was I give you the scale factor and the real measurement, and we had to find the map one. This time, last type of question, is I'm going to give you both the real and the map measurements, and you've got to make your own ratio. You've got to make the ratio out of it. Okay, but remember that the order is important. Go back a page if you need to. Which number comes first? The map, or what do we call it? I called it the scale drawing. The drawing length or the actual length? The drawing length should always come first. So of the 2 numbers that I have here, I have 5 millimeters on a scale drawing represents 50 centimeters in real life. So my ratio is going to be 5 millimeters for my scale drawing to 50 centimeters in real life. But ratios should not have different units, and they should always be simplified. So we've got to keep going. Okay, I don't want to have to go to a decimal, so I'm going to change the bigger unit into millimeters. How do I change centimeters into millimeters? Someone other than Ethan, please. Yes, good. All right, if I times this by 10, I get 5 millimeters and 500 millimeters. Once they're both in millimeters, we don't actually need the millimeters on there anymore, okay? So now I can just simplify the numbers. I have 5 and 500, so this is good practice. What can I divide both of those numbers by? Somebody, yeah, Ethan knows the answers and he's trying to give someone else a turn. Yes, Noah? 5, perfect. 5 divided by 5 goes once, and 500 divided by 5 is 100. Okay, so that would be the scale factor that you would put on your scale drawing if they were the measurements you were using. Remember that you can use your calculator to simplify ratios if you need to. You just type in 5 over 500 and press equals, and it gives you the simplified fraction 1 over 100. You just have to remember to write it as a ratio again. Don't write it as a fraction. Okay? All right, let's do the last one. Part B. An actual length of 0.2 millimeters is represented by 10 centimeters on a scale drawing. Okay, now remember the order is important. Which one goes first? The actual length or the scale drawing one? The scale drawing should be first. So they're actually written in the wrong order here. The scale drawing goes first, which means the 10 centimeters should be first. And the actual length of the object, the 0.2, should always be in the second spot. Okay, again, my units are different. Millimeters is the smaller unit, so I'm going to change 10 centimeters into millimeters times by, yes, times by 10. So 10 times 10 makes 100 millimeters and 0.2 millimeters. Okay, they're both in millimeters, so I don't have to worry about the units anymore. But I do have a decimal in there. Okay, we're going to do it without the calculator first, and then we'll come back to the calculator. If you are trying to get rid of a decimal in your ratio, you need to multiply by some lot of 10. If it's one decimal place, it's just 10. You multiply by 10 because it jumps the one spot. If there was 2 decimal places, you'd multiply by 100. And 3 decimal places, you'd multiply by 1,000. You get the idea, right? So this number here has only one number after decimal place. So I just want you, like a balanced equation, I'm going to multiply both sides by 10. So I'll write that on the top here. I'm going to times that by 10, and I'm going to times that by 10. That's going to give me 1,000, I don't need the millimeters anymore, and 0.2 times 10 is 2. Now that my numbers are whole numbers, I want to see if I can just simplify normally. Can I divide those by something? Yes, Layla, what? 2. All right. 1,000 divided by 2 is 500, and 2 divided by 2 is 1. Okay, back to the calculator part now. So if we were back here with the 100 and the 0.2, you can type that in as a fraction as well. So 100 over 0.2 and press equals. It will give me the 500 because remember, if the second number in the ratio is a 1, it won't put 500 over 1. Calculators won't do that. They will just, you need to know that second number is a 1 if you're trying to do the shortcut with your calculator, okay? Okay, the other thing that's different about this ratio is that the 1 is in the second position. All the other ones that we have done had the 1 in the first position. That's because most of the time, when we're drawing maps or scale drawings, the map is the smaller version of a much, much bigger object, okay? But it doesn't always have to be. In this particular case, this means that we have taken a small object and we're actually making it bigger on our scale drawing. It's actually 500 times bigger. So it could be something, what's something that's, is an ant? Probably not. Maybe it's a really tiny bug. Is 0.2 millimeters long, and when you drew, a scientist or someone drew a scale drawing, they wanted to draw it really, really big so they could label it and put all the different parts on it. They made it 500 times bigger on their scale drawing of that tiny little insect. Okay, so that's what that means. If the bigger number is first, it actually means that the real life thing is bigger than your scale drawing. Sorry, that's the other way around. Your scale drawing is bigger than your actual little thing, your little bug. Okay, hopefully you get the idea. Let's get started on the question.